Hey guys, so in this video we are going to talk a little bit about bad technology, old technology, and why people use things that aren't all that great. So let's get into it. Now, there's a million reasons as to why someone uses a piece of technology that you may not think is the best idea, and there's no definitive answer to this. But what I want to touch on in this video is a little bit of, I want us to have a little bit of a perspective on our industry and software development. And I want us to kind of consider something that I think is lost in this. It's almost crazy. It's almost, I don't know. It almost feels like it's backwards, at least if you look at what's happening out on the internet and how new developers are being introduced to software development, and not just new developers, almost all developers. You see, the thing is, guys, when somebody makes a technical decision based on something or other for a company, if you're building a product of some sort, you're basing this technical decision on your circumstances. And those circumstances are the thing that determines what solution you go with. And depending on the solution and depending on the situation, you will have different pros and you will have different cons. And it's very easy, and this happens quite a lot, where somebody external, from an external perspective, takes a look at what you made or like you built. And here comes the thing that I kind of use to sort of almost determine somebody's level of experience. It was something that I did when I was first starting out, where I would do what my coworkers call the code mock. Now, the code mock is that you have some new person join a project and they start talking about refactoring, they start talking about how crappy the code is, and oh, look at this piece of code here, how could you ever do it like that, etc., etc. And then you have the other ones who talk about rewriting things in new languages, new tools, and all of these great things, right? That's what my coworkers call the code mock. You're mocking the software that is already there. And for a very long time, I actually believed myself that, I did it. I mocked code, and I don't know. As I worked, I started to kind of pull on some strings and try to, because the thing is, when you're just being introduced to something and you look at it, it's very easy for you to just say, hey, this could be much nicer. And at the time, I didn't know why my more senior coworkers just sighed at me and like, yeah, of course it could be nicer. And then they kind of just left me to my own devices. And so I thought, all right, maybe it's just that they're lazy. No worries, I'll fix this. So I started pulling on a bunch of strings and thought, hey, wait a minute. This thing here is connected to that thing there. So I can't really change that as easy as I wanted to. Because my mentality that I had was that, oh, this would be easy to refactor or make it nicer. Or switch it over to something better. And after having this, after getting caught in this mental trap a few times, I started seeing a pattern. I started realizing that it's actually funny that why am I trying to improve on something that I don't really understand all that much? Because let's remember something. The technical decisions that have been made on behalf of the project. In other words, if you choose a language that is, like whatever language you choose, like take Java for example. Java is my go-to for this sort of issue, where a lot of people will hate on this language because it has all these limitations that they talk about, like speed, performance, all of these things. Those are the things that you focus on when you are the third party. But when you're actually implementing the thing and you actually build the thing, you have a certain set of requirements that you need to fill up. As an example, have you ever considered that when somebody picks Java, it has absolutely nothing to do with how powerful the language is, or how fast the language is, let's call it that. What if the technical decision to go with Java is simply because it's easy to get people for it? What if that is the requirement? What if at the time of building the project, you have no choice because there's a contract that you're tied into with an external party, and where they have a certain amount of say, and they only provide you with Java competencies, so you're forced to use that. In my project, we use Scala. Is that the best technical decision for that project? Well, no, because we are right now spending quite a lot of time trying to educate people in Scala, and that's much trickier than finding and educating people for Java. And the gain isn't all that big if you think about it today. But if you think about it when the project was actually started, you start to think about, all right, what were the technical limitations? What were the requirements at that time? What was the situation? And see, that's where this kind of idea that you will have, that's where you're missing something. Some people will tell me that, oh, Go is the best language. Just the other day I had this subscriber who came on, who left a comment, and like I was comparing C# and Java, and this person stated that, oh well, that's not a problem because Node is better than both. Now this is the sort of person that I will argue just this exact as I said, this mental mistake they make, which I used to make, is that they know of something in their little world that is better, quote unquote, so they immediately have the perspective that, oh, it's a mistake to use C# or Java and so forth because Node is so much better. But that's, as I said, that's a mental mistake. It's completely false. And I tried to explain this to this viewer. I was saying that, well, it kind of depends. Let's take Java, for example. I mean, in Node, does it make sense to make a graphics rendering, like a game, like a desktop game in Node? Well, with a single thread, it's not a great idea. Does it make sense for, I don't know, thread-based programming, where you need to be able to run several things in parallel? Well, no. Is it a good idea for high precision mathematics? No. Is it maybe money calculations? No. How about high CPU usage computations, like encrypting things or compressing things? Gzip, I mean, even such a thing as gzipping isn't all that great to do in Node. And then the creme de la creme, the crescendo of this little argument that I presented. I wonder how easy it is to find people with a high level of education in Node versus in Java. Because if you think about it, the world's most popular language is JavaScript, not Node. And in second place comes Java. And Java doesn't have doesn't have a monopoly on being the only language supported in the browser. That's pretty good. So you see, when you start to factor these sorts of things in, when you start thinking about, when you start letting go of the sales pitch, guys, because that's what it is. The sales pitch, the people who are pushing their languages and they're pushing all this technology, they want to convince you that their solution is the best. And although it is true that you can always make things nicer, you have to stop thinking so much about a perfect solution. You have to start thinking about what is it that made this solution into what it is today. I mean, today, I have a very different mindset when I look at software. I don't think about, like, the first thing I look at when I look at the quote unquote ugly piece of software is not, oh, this is ugly. That's not, my first thought is not, this is ugly, I should rewrite it. My first thought is, this is ugly. I wonder how it works and why we got to this point. And then when I understand why these technical decisions have been made, because that's the whole thing. It's the same thing with anything. A great example, if you see somebody, if you build a modern building, a skyscraper today, you can appreciate the engineering and all the work that goes into it, but what you don't compare You don't compare an old building from like way back to a skyscraper in the same way. It's you have the capacity to see that, all right, that building was built a long time ago, and under the circumstances, considering the times and the practices back in those days, it probably made sense to build it that way. This is the same sort of thing, guys. If you see something that you work on a project that has all this outdated technology and all these outdated practices and so forth, don't judge that code with your modern day eyes. Try to understand why these technical decisions were made at that point in time. And then when you understand why it works the way that it works, you make an evaluation. You try to ask yourself, is it worth migrating this? Is this code working well enough, or do we need to fix this because it's causing us a lot of pain and issues? Same thing with the skyscraper, like the buildings, guys. When a building will stick around for as long as it's providing value. And when it gets to a point where it's simply too costly to maintain a really old building, you tear the whole thing down and you build a skyscraper, or you build a modern building. That's the same thing. But in order for that to make sense, you're not just updating every building in a city every single year just because it's a little bit outdated. It has to get to a point where the cost of maintaining this old way of working, or this old legacy, or whatever, is so, like, that cost needs to be so high that it's actually worth migrating to something better. That's at least the mentality that I have these days. Have a great day.